What if the next extinction-level event isn't just one disaster, but two colliding into an unimaginable cataclysm? Imagine an asteroid impact triggering the eruption of a supervolcano. An event so rare, so devastating, it could wipe out life as we know it. Could humanity survive such a double whammy? Hey, let's dive into this wild idea together. I've been obsessed with these doomsday scenarios ever since I first heard about Yellowstone's hidden fury and those rogue rocks hurtling through space. It's not just sci-fi fodder. There's real science backing up the possibility that an asteroid smash could poke the bear, or in this case, the magma chamber, and turn a bad day into an apocalyptic nightmare. We're talking about forces that have shaped Earth's history, from wiping out dinosaurs to potentially reshaping our future. Grab a coffee, because this theory weaves geology and astronomy into a tapestry that's equal parts terrifying and fascinating. First off, let's set the stage with the stars of this catastrophe: supervolcanoes and asteroids. Supervolcanoes aren't your run-of-the-mill lava spewers. They're behemoths capable of ejecting over 1,000 cubic kilometers of material in a single go. That's like filling the Grand Canyon a dozen times over. Yellowstone in Wyoming is the poster child, sitting atop a massive hotspot that's been brewing for millions of years. Asteroids, on the other hand, are those chunky remnants from the solar system's birth, some big enough to pack a punch that rivals nuclear arsenals. The theory here? A hefty asteroid strike could send shockwaves deep into the Earth, destabilizing magma reservoirs and kicking off a supervolcanic eruption. It's like dropping a bowling ball on a Jenga tower filled with dynamite. But to really grasp the horror, we have to break it down. Let's start with what happens if Yellowstone decides to wake up on its own. No asteroid needed. This is where the global winter kicks in, and trust me, it's not the cozy kind with hot cocoa. Picture this. You're chilling in your backyard, maybe grilling burgers, when suddenly the ground rumbles like a freight train from hell. That's Yellowstone stirring. This sleeping giant isn't just a national park gem, it's a caldera, a massive volcanic depression that's erupted cataclysmically 3 times in the last 2.1 million years. The last big one, about 640,000 years ago, blanketed half of North America in ash. If it goes off again, we're not talking a gentle puff. We're looking at an explosion that could rival the force of 1,000 Hiroshimas. Right off the bat, the immediate aftermath would be brutal for anyone nearby. Pyroclastic flows, those superheated avalanches of gas, ash, and rock racing at hundreds of miles per hour, would incinerate everything within a 100-mile radius. Think Pompeii on steroids, forests vaporized, cities like Salt Lake or Denver buried under feet of scorching debris. Infrastructure? Forget it. Roads, power lines, airports, all choked with ash that acts like wet cement when it rains, collapsing roofs and grinding machinery to a halt. In North America, we're talking millions displaced, economies tanked, and a humanitarian crisis that makes hurricanes look like sprinkles. But the real kicker comes next. The ash clouds. Yellowstone could hurl billions of tons of fine particles high into the stratosphere where they'd linger for years, blocking sunlight like a cosmic curtain. This isn't hyperbole. Historical eruptions like Tambora in 1815 caused the year without a summer, with frosts in July and widespread famine. Scale that up to Yellowstone levels, and global temperatures could plummet by 5 to 10 degrees Celsius for a decade or more. Crops would fail across hemispheres. No wheat in the Midwest, no rice in Asia, no nothing. Ecosystems would unravel. Acid rain poisoning rivers. Forests dying from lack of sun. Animals starving in droves. Billions could face food shortages, sparking migrations, conflicts, and a domino effect on global supply chains. It's a volcanic winter that turns our blue planet into a frozen, dusty wasteland, where survival boils down to stockpiles and sheer luck. Recent studies tweak this a bit. Some say the cooling might not be as severe as we once thought, with sunlight blocking aerosols dispersing faster than expected. But even a milder drop could still trigger mass extinctions and societal collapse. And here's where it gets scarier. What if this isn't solo? What if an asteroid lights the fuse? Shift gears to space. Asteroids are sneaky bastards. Chunks of rock and metal zipping around at 20-50 kilometers per second. We've got eyes on many thanks to NASA, but surprises like Chelyabinsk in 2013 remind us we're not invincible. A big one, say 10 kilometers wide like the Chicxulub crater maker, hits with the energy of billions of atomic bombs, vaporizing rock, triggering tsunamis, and igniting global firestorms. Dust and soot block the sun, plunging us into an impact winter similar to volcanic chill with temps dropping and photosynthesis halting. On its own, an asteroid strike could kill billions through immediate blasts, fires, and long-term starvation. But the twist in our theory? If it lands near or antipodally to a supervolcano, opposite side of the planet, the seismic waves could converge and squeeze magma like a tube of toothpaste. Earth's crust isn't solid. It's a jigsaw of plates floating on molten goo. A massive impact sends shock waves rippling through the mantle, potentially fracturing reservoirs and forcing eruptions. Now, marry the two. Imagine a Chicxulub-sized asteroid slamming into Earth, say, in the Pacific. The initial crater is a hellscape. Ejecta rains down, wildfires rage, oceans boil into acid rain. But underground, those shock waves travel, focusing energy at the antipode, which, depending on the hit, could align with Yellowstone's hotspot. Yellowstone's magma chamber is already pressurized. Add seismic jolts and boom, eruption triggered. The combo? Double winter. Asteroid dust plus volcanic ash create a thicker veil, extending cooling for decades. Global temps crash harder, maybe 15-20 degrees, turning tropics into tundras. Food webs collapse utterly. No plants, no herbivores, no us. Acidification hits oceans, killing marine life. And the ash? It exacerbates respiratory diseases, clogs tech, and poisons soil for generations. Is this likely for Yellowstone specifically? Not tomorrow. The volcano's not primed for a super eruption soon, and asteroids that big are rare. But models show large impacts can melt rock and deform the mantle, sparking volcanism. A direct hit on Yellowstone? Even a 1-kilometer rock might not fully trigger it, but a bigger one could fracture the caprock and let loose. This isn't just speculation. History whispers warnings. 66 million years ago, the Chicxulub asteroid hammered Mexico, creating a 180-kilometer crater and triggering mega tsunamis. But around the same time, India's Deccan Traps, a flood basalt event akin to a drawn-out supervolcano, erupted massively, spewing lava over 1.5 million square kilometers. New evidence suggests the impact rang Earth like a bell, accelerating Deccan eruptions by shaking magma loose. Seismic energy densities from Chicxulub could have triggered the largest lava flows, accounting for 70% of the Deccan's volume. The 1-2 punch, impact's immediate kill zone plus volcanism's toxic gases, sulfur, CO2, caused acid rain, ocean acidification, and prolonged cooling. Dinosaurs didn't stand a chance. 75% of species vanished. Recent 2025 studies reinforce this connection, casting doubt on impact-alone theories and highlighting how volcanism amplified the chaos. If it happened then, why not again? All right, the big question. Could we make it? Short answer. Maybe, but it'd be grim. With tech, we could detect asteroids early. Think NASA's DART mission proving we can nudge them. For volcanoes, monitoring Yellowstone's swells and quakes gives warning. But a combo. We'd need bunkers, seed vaults like Svalbard, and geoengineering to reflect sunlight or capture ash. Survival odds. Urban areas near ground zero? Toast. Globally, famine could claim billions, but isolated spots like New Zealand might fare better with geothermal energy. Humanity's ingenuity, hydroponics, nuclear power, international aid, could pull us through, but at what cost? Societies might fracture into survivalist clans, tech regresses, and recovery takes centuries. In the end, this theory reminds us Earth isn't forever safe. It's a call to watch the skies and the ground, because the next big one might not come alone. What do you think? Ready to build that bunker yet?